let's continue on with this problem. So we're going to keep using that equation. So if you remember back in the problem, the first thing I wanted you to do is I wanted you to calculate the slope of the line, okay? Well, if you remember, we are looking at the place where, and in this case, it is going to be a equals 3. So since we have that equation, okay, since we know the derivative of the function is equal to negative 32a, okay, how do we find the slope? Well, we're trying to find it at a equals 3 seconds. So guess what you do for that? You just substitute it in. We want to find f prime of 3. So it's going to be negative 32 times 3, and negative 32 times 3 is negative 96, and in this case it's going to be feet per second, because what the derivative finds is it finds the slope of that line. And if you remember on the graph of this function, it was feet over seconds when we were taking a look at this on a previous problem. So it's feet over seconds. So this is the slope. Now, it didn't ask you just to find the slope. It also asked you to find the tangent line. So we use the equation. Now we need to find the tangent line. And if you remember the formula to find equations of a line, the formula that we use the most often is we use point slope form. Okay? We are going to use point slope form. So the thing you need to remember is these two variables, the y and the x, are always left in the equation. The two things, or the three things you have to find is you have to find those things. Okay? So remember, we have the point at a equals 3. So in order to use point slope form, and remember this is point slope form, in order to use point slope form, you need a point and you need a slope. So let's start thinking about this. We need a slope. What did we just calculate in the previous section? We calculated the instantaneous slope when it was time equals 3. So we know our slope is negative 96, and we can put the label feet per second, but remember in the formula we're not going to use that. So it's negative 96, okay? But we need a point. Well, we know only one thing about the point. We know the first coordinate. We know that it's at 3. So how do I find the y coordinate at 3? Well, remember, you were given in the very beginning, you were given a function that helps you figure out every point that's on that line. So we have to go back to that original function. The original function was negative 16 x squared plus 594. So I want to figure out what that value is. So we're going to go negative 16 times 3 squared plus 594. Could you do me a favor?
Yes.
Could you do this negative 16 times 9 plus 594? 450. So our y value is 450. Okay? So we now have a point. We now know the slope. So now you need to just figure out the equation of the tangent line. So what is that equation going to look like? Well, we know it's going to be y equals, and I know we're going to keep the x. We just need to fill in the other pieces. The y coordinate of our point. We look right here. The y coordinate is minus 450. The slope is negative 96. The x coordinate is 3. This is the equation of the tangent line. Okay? So that's the second thing they wanted you to calculate. So they wanted you to find the slope. They also want you to find the equation of the tangent line. There is a third thing. So if you remember, the third thing is C, the equation of the normal line. So the equation of the normal line is just the equation of the perpendicular line. Okay? So it's the equation of the perpendicular line. So we're still going to use the same point slope formula. We're still going to use y minus y1 m minus x1. So the two things we need is we need a point and we need the slope. If you remember, we already calculated our slope. Okay, our slope was negative 96. But it's not negative 96 for this one because we are finding the equation of the normal line. The normal line is perpendicular to the original line. So if you remember, for perpendicular, you have to take the opposite reciprocal. So we need to flip the fraction over and change the sign. So it is going to be 1 over 96 is our new slope. Okay? Now, the point, though, is still the same point. We're still going through 3 and 450. Okay? So we're still going through that exact same point. Now, what do we do? Well, we use the same formula and we plug our numbers in. So we know we have y equals and we have x. We just need to plug in the numbers. So first of all, our y coordinate is 450. Our slope, in this case, is 1 over 96. And our x coordinate is 3. So what is our equation for the normal line? This is the equation for the normal line. Okay? So when you're going through and you're working with these types of things, you have to do a lot of work to find all of those pieces. Okay? So when you're trying to figure out the equation of normal lines and tangent lines, the first thing you always have to find is you have to find the derivative of the line at whatever point that is. So find the derivative and then find the slope. Okay, so figure out what that slope is going to be specifically. Then, using that information, you need to find a point and you need to use that slope to find the equations of the line. We will always defer back to point slope form when we are trying to figure out these lines. So remember, a normal line, though, perpendicular to the tangent line. So remember to use that opposite reciprocal stuff. So hope you have a good one, and I'll see you in the next video.